Hi dear students, let's see this question that came in KVPY 2019 SX part 1 physics paper. So in this question, basically this question is from the topic of Bohr's model, but again it's a very simple, fairly easy question. So in this question what's happening is that instead of assuming that that we have a single proton in hydrogen atom, we have to assume that the charge on the hydrogen atom, or the rather the charge on the hydrogen nucleus, is distributed over a volume, or a like it's it's distributed over a whole volume of radius 0.25 angstrom. That means, what is original hydrogen atom? So we have a nucleus which has a charge, sorry, which has a proton like this, okay, and according to Bohr's model, we can say that electron revolves around it in a circular orbit. So here we have a point charge and electron revolves around it in a circular orbit. This is what hydrogen atom is, correct? Now this question says that if we assume Thomson's model instead of Bohr's model, so basically the charge will be distributed over a solid spherical region of 0.25 angstrom radius, okay, and electron is going to revolve around it. So what is the difference between two models? Here we have a point charge and here we have a positive charge distributed over a, yeah, spherical volume of radius 0.25 angstrom. That is the only difference, okay. Now we have to apply Bohr's model on this in this situation, and we have to find the ground state energy of the electron, right? Now let's understand, let's try to think that will the answer change. Think, answer will not change. Answer will still remain minus 13.6 electron volt. Why so? Because if you think carefully, the electric field of a point charge and the electric field of a sphere outside the sphere is always same. See, you are going to make same two equations in both the scenarios. What is the force equation that we would have written over here? K into charge on proton, which is magnitude wise electron only, charge on electron, which is magnitude wise E only, kq and q2 by r square is equals to mv square by r. This is the force on the electron, centripetal force on the electron, that we would have written. Here also, whether the charge is distributed in a spherical volume or not, outside the sphere, the electric field will remain the same. Hence, we are going to write the same equation: k square, k into k into E divided by r square. So this will be the Coulombic force, that will be equals to mv square by r. So you can see that same equation we are writing for the force. And second equation will be, of course, mvr equals to nh upon 2 pi. So this is the angular momentum conservation equation, which also remains the same. So if you are starting from same two basic equations, so end result will also be same, because further mathematics will remain the same. And hence, ultimately the answer will also come out to be same. So you can see there is no change in the energy of the electron in the ground state. I hope you would have understood the reason why the energy remains unchanged. That's it. Thank you.